Hey everybody, it is office hours. If you are here, what questions do you have? It is time to do some work. Woo, went and got a snack, saw a bunch of people, and said hey. So really thankful. There's so much positivity on campus. Huge shout outs to Vicky in the Vol store or the Vol shop, Vol Snacks. Best place to go get snacks, in my opinion, on campus. Anybody here in the chat who is here? We've already got that saved, so we're good on that. What is due? We could do some chapter 6 quiz stuff. Kind of go from the beginning, maybe? Might start working on that. My Pearson Lab. Sign into our course. Okay. How are people doing? I'm going to look at the incompletes. If you're in the chat, I'm not muted right now. That's good. Also, am I muted? And then no one could hear me. Like yesterday's office hours. Manage incompletes. Okay. Uh-oh. A few people didn't do chapter 5, so we need to select the past due and submit those. Start at the very beginning of chapter 6 homework. We've done the Canvas content. So we have the Canvas content here. Chapter 6 homework and quiz are due tonight. Canvas content is due tomorrow, along with the pivot chart and pivot table. And looking like pretty good. And the exam is coming up. Okay, no one's here yet. I'll just start doing some of the assignments myself. That's fun, right? Get working away. Okay, got a new page. Chapter 6 quiz. Let's see how many of these we can do. Probably do a few. We've done that one. We've done a lot. If I see one we've already done a lot, then we'll continue on. This one's fun. Let's do it. Okay, let's take the note in the chat on the question. This is chapter 6 quiz. And this is going to be chapter 6 quiz, good. Stats 101. Chapter 6 quiz. Consider the following data. And we are here currently at the 3:52 mark. Okay, so consider the following data. Now you could do this inside of Jump, but you don't have to. Because when you look at the data right here, as number of people increase from 2 to 4 to 8 to 11, 11 to 15 to 15, 15, a lot of 15s. It's craziness. Notice how there's a bunch of 15 points, which means at the end of the series, for number of salespeople working, you'd have to see a lot of 15s. This data doesn't show that. Over here, you don't see a lot of people working at 15. The amount of people working would be right there. So what you should see is something more like this with a bunch of people working. Now, some of these dots are overlapping, like the ones at 22 are overlapping. This is probably the right answer. But another thing to note about this is, too, as we see more people working, we see more sales. This one indicates a negative relationship. It does have the dots here at 15. This one indicates a weak/non-existent relationship, kind of a weird one because it starts out like that and like that. But the one we want is the one where we could trace the points to it. Notice how this person right here has, or this occurrence is only 2 people working, and the sales is 17 in thousands of dollars, because this would be right here. That's 5, that's 10, that's 15. I wish they labeled more on here. And that'd be 17. Also, that's 17. But now we have 4 people working, because this is 5 people working right there, and that'd be 4 people working. The next one here should be 18, 19. And that would be 8. I said 18, but that should be 8. That looks about 8. And then over here, this would be 19 because that's 5, 10, 15, 20. These 2 dots right here have the same value of X, and you see that right there. And then there are 5 dots right here. It's just 2 of the dots are overlapping because they have the same values. So you should be able to figure out this is a positive, mostly linear, strong relationship. And that goes to the next question, which says it's positive, it's mostly linear, it's pretty darn strong, and there aren't really any outliers. So that should do it for the question. There could be differences among these plots where we do see outliers and things like that. If we were to have, we should make it a little bit bigger before we do that. When would it not follow these relationships or not be well described? So if it was nonlinear, it might have something towards the end that goes like this. That would be nonlinear. If it has bigger outliers, you might see something where there's a point down here that doesn't follow the trend. If it was weaker, it would be more spread out and look like a blob. The fact that it is a very tight relationship means that it is very strong. The tighter it is around the form, which in this case is linear, is the stronger it is. So remember, the things to understand from this chapter are strength, direction, form, unusual features. Going back to the notes right here, you should have some good notes on what is strength, what is direction, what is form, and unusual features. This is chapter 2 over here, which is shape, center, spread for histograms, but that's a good review of the concepts of strength, direction, form, unusual features. Let's check out the next one right here. Not question 4. Ooh, this one looks got some more details on it. If you're in the chat, feel free to say hi. We can do your question that you're working on. Want as many people as possible to use this video. People be like, whoa, disk drives have been getting bigger. Now you can get terabytes. Okay. With this right here, you'll notice that the disk drives are getting bigger and bigger and bigger, and the price is getting more and more and more. And there is one that does break the trend, that the 3 terabyte apparently costs less than 2 terabyte. That's why would you ever buy the 2 terabyte then? But if you notice, because they're both increasing, positive correlation means as one increases, the other increases, or as one decreases, the other generally decreases. Negative correlation would be something like I guess it would be the more hours you spend playing video games before the test. And I like some video games. The more hours you spend playing video games before a test, the lower your test grade. And, I love some video games. But that might be negatively correlated. More video game play, less test grade score, so they go in opposite directions. Maybe. We might need to examine this and play some video games. But this is positively correlated because the higher the capacity, typically the higher the price. And we only see 2 positive correlations right here, and that one has a break in the trend here on the third to last because it goes up, 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 and then there's this jump downward, and that's not what we see on the third when it goes up, 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 except for the one that breaks the mode a little bit. We see this one does have this up, 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 up trend, and then there's this big gap in size of hard drive between 12 to 32, and there's a little gap here from 8 to 12, and there's a huge gap in price from $1,000 to $4,468. Now, this is a somewhat curved relationship. It's definitely positive, and it is a little bit curved. And what do we mean by that? We mean it doesn't perfectly follow a line. So this is the form. Make sure you've written down what the form is. This was a linear form. And then over here, we have not great linear. It's not horrible. But here's the thing, and this did trick me yesterday. That's why I'm redoing it. This point follows the parabolic form. It doesn't perfectly follow a line, which tricked me, because a line does not fit the data perfectly. The line kind of fits the data if we could draw through the data. But what fits the data better is the parabolic or curved non-linear form. I wish they just said non-linear, but it does have a pattern. It is not linear, and that is the curve. How strong is it? Don't worry, a lot of people get this wrong. I wish there was someone in the chat so I could quiz you. I know why you're not here. Mubot has not re-woken up yet. We got to re-wake up Mubot. The deal with this relationship is it's super duper strong. This is, Mubot, go away. This is about as strong as it gets because the points are tight around the form. First, analyze the form. Draw the form on the relationship. Then see how tight the points are around the form. And this is extremely strong. So it's no question in my mind that that's super duper strong. Now that point over there basically follows the pattern. What did I get wrong today? Oh, because the 32 hard drive follows the pattern. I was so excited to answer no that I didn't even read what it said. They're like, oh, there's another no. The last question here I don't love because it's all right. We're on speaking terms. It's because if you think about this following a curved pattern, which it does, that point basically conforms to the curved pattern, which it costs kind of an exponential growth to what things cost as you get to bigger and bigger hard drives. Like maybe a 400 terabyte hard drive would be very, very expensive, like $1 million or something ridiculous. Because you get this exponential relationship of it, more hard drive space, all of a sudden price starts to exponentially increase because you're building some sort of crazy hard drive. And that is something that follows it, although the 30 terabyte hard drive is far away from the rest of the data. It does seem to follow the general pattern. So the last question there is very much up for debate depending on how we fit the data. And I could do some bigger analysis on this and see if the linear model is appropriate or not appropriate with some other statistics. But don't worry, we're going to do some more questions right here. Okay, the next question here at the 11:32 mark. And let's do this. And we are going to do if we want. That's easy. If we want to study the relationship between two quantitative variables such as fat in food, and calories in food, what would we make? Now, you should be able to draw each of these out. If you really understand these topics, you need to do a drawing for each one of these. So what would we draw? We go right here. And with this, I'm going to do one thing right here. I want to make sure I don't. It's got the little manila folder. I don't need that. Unpin from taskbar. Can I not unpin that? There we go. And that's much better. I don't like having that on my taskbar, so I don't click it. And so here we are with the following graphics. If you want to understand calories and fat, what would we do? Well, we do the following. We choose one of these graphics, but the type of data we're analyzing helps us pick the graphic. And the answer to this question is simply on this screen. Now, calories and fat is going to be quantitative. That means you're analyzing a bivariate relationship, calories and fat. You're in this realm right here, this window I'm pointing to right there. But here's the thing people get wrong, is when you're doing calories and fat, that is two quantitative variables. It's not a time plot, though, because a time plot would be if you did something like the price of milk or eggs. Yeah, how topical. The price of eggs has two G's, apparently. And that would be dollar price of egg over the year. So this is a time plot because the year, with an extra E at the end, I don't know how to spell. The year is a time variable, and that makes it a time plot. Technically, just calling this a time plot. Time series plot, time plot, all that good jazz. So histograms are when you analyze one quantitative variable. Side-by-side box plots are when you have a categorical X. So now we'll do this different color right here. We'll do it in a nice light orange, categorical, and you'd have a quantitative measurement. So you're still analyzing something. You could do the price of eggs in Tennessee versus the price of eggs in New York. Maybe this is New York and this is Tennessee, and the price of eggs in different grocery stores might be a little bit lower in Tennessee. And so this is now another price thing right here, or quantitative metric. And that would be side-by-side box plots. And so you couldn't do fat and calories. You'd have to do something like fat in dessert items versus fat in entree items. Notice that entree or something like that, like the type of food we're eating, so the fat in like the type of food. And that is a categorical variable. My gosh, can't spell today. So the type of food you're eating or the state would be categorical for side-by-side box plots. Side-by-side pie charts is going to be something down here where you might compare what people put in their grocery cart, whether they are a student or not a student, and you could look at percent of snack foods bought maybe. So maybe the students are buying this much snack food. I don't know. I've not been a student for a while. And then the non-students we're probably still buying some snack food. The non-students are buying this much snack food. So you could then do comparisons here and notice this is bivariate because you have snack food, yes versus no. So this is yes snack food, no snack food, yes snack food, no snack food. And a side-by-side pie chart is a bivariate display. It's actually down here near the mosaic. Side-by-side pie charts or stacked pie charts down here. So that is a bivariate categorical, cat. So this would not be how to display two quantitative variables. So the display for two quantitative variables is going to be the scatter plot. And do know these other ones. Once again, that screenshot, if you take it, shows you all the different types of ways to display data. And remember, it's pretty easy right now because we're in the scatter plot chapter. So you're like, oh, it's a scatter plot. But then later on, when you're taking the test, it's like, how would we display, I don't know, your income and also your job title? And income versus job title would probably be side-by-side box plots because income, Y variable of interest, job title, X variable. So that's how we would display it. In a scatter plot, let me mark this right here. $16, $13. Oh, well, I got a lot of sleep last night. I'm still tired. In a scatter plot. Went to bed like 9:30. Slept till like 6. That's a good, it's 10 hours, isn't it? Yeah, 10 hours. But I was tired, getting like 6 hours. Wake up. In a scatter plot, we try to describe the direction of an association. A positive direction would be Howley. Draw it. Best thing to do is just draw a positive correlation. So what you want to do right here if you're working on this problem is draw a positive correlation. Always try to do drawings, practice it. It helps you remember better. So when you do a positive correlation, there's a positive linear correlation. So it starts here in the bottom left and it goes to the top right. So from the lower left, that sounds like lower left, to upper right, that sounds right. And there we go. Once again, the more you can draw it out, the better you can do. Try drawing these things out. Once again, draw it out. That's what we do right here. What is the best way? Let's do short, quick questions. Quick, multiple choice. Phone keeps buzzing. Phone keeps buzzing. Okay, in-person office hours. What? All right. Which of the following best describes the explanatory variable? The explanatory variable, let's see right here. The explanatory variable causes changes in the response. No, it doesn't cause. Cause is a bad word in this class. Don't say it causes something or must or whatever. The explanatory variable explains or predicts changes in y. The x predicts y. The x explains y. True. The response is the y variable of interest. Important thing to know, and this will be the right answer here. We found at least one wrong answer, so now there can't be all of the above. The explanatory variable is the x variable. So when you hear explanatory, you should think x variable. The response is the y variable of interest, and the x either explains or predicts what happens in y. We do not like the word cause in this class because we don't say things cause each other, like correlation is not causation. So that's wrong right there. And it would be the independent variable. When you look at a regression equation, which we'll get to shortly, it's y hat. I wanted to do black. Y hat equals b0 plus b1x. And that makes this the dependent variable over here, and this is the independent variable. So the x is the independent because you can independently choose values of x and solve for y. If you ever wonder why y is the dependent, whatever you plug in for x will then solve for y in the equation, as we do solve for y. And so the value of y depends on what x is in the equation. So it is going to be that one right there. Can't be all of the above because we found at least one, found two wrong ones. Okay. Let's do this one. We're going to do like the whole thing, aren't we? Oh my God. I don't know. I could do it. Speed run them all and do them real quickly, but what's the point of that? Then no one learns anything. Say, come on, Ryan, do it. Speed run them. I know you can. But you can't do it, Brian. Oh, you bet I can't solve all these really quickly. I'll do it. If we assume, I like that people have these videos to reference, and I've done these questions a lot, and every once in a while I'll get something wrong, because I got this wrong one time, and I'll rethink it, and I'll think the wrong answer is the right answer, and I'll just outthink myself on a question or two. I've done it for years. Rethought a question and be like, wait, okay. A correlation of 0.02 indicates a strong positive association. No. Correlation has values that range between -1 and 1. These are the notes you want to have and the understandings you want. The correlation ranges between -1 to 1. Where -1 to 1 are equally strong, you can see right here on this slide. We'll go to the main screen for this. -1 to 1 are equally as strong. A correlation closer to 0 indicates no linear relationship. It doesn't indicate there's no relationship. It indicates no linear relationship. So the bottom right here, especially this one, has a relationship. It's just not linear. Other ones are a bit weird, odd relationships, but 0 is the weakest linear relationship. So let's go see what it said again. Strong, positive, no, that's a non-existent. The correlation coefficient, no. Correlation of 0.02 indicates there may be no linear association between the variables. Standardizing the variables will make the correlation close to 0. No. Standardizing the variables actually happens when we do the regression equation, because if you look at the regression equation right here, we turn them into z-scores. And that's what's going on when we say standardizing. So standardizing the variables turns them into z-scores, and that already happens. So
it doesn't matter.
Doesn't matter. This is very false. Standardizing the variables will not change anything. Standardizing the variables, changing the units will not affect, because correlation is unitless. It's based on z-scores. Adding an outlier can dramatically affect correlation. True. Facts. Outliers can do anything to correlation. They can make a weak correlation strong, a strong correlation weak, a positive correlation negative, a negative correlation positive. Take, for example, right here, we'll go to view, and we'll go to actual size, and let's go to core demo. So if you take a look, we have a core... Oh, I thought it worked when I did actual size. Let me get out of here. View. Actual size. View. I thought it worked with the actual size. Oh, okay, good. It's working now. Here we have a correlation of basically 0. No? Oh, I got to go up. There we go. Correlation of 0. So now we had 1 dot, and the correlation is almost 1. 1 point brought the correlation from 0 to almost 1. And if I could move the point even further out here, it would make it even stronger. Just notice here, it's 0.57. Here, it's 0.39. As you go further out, it gets even stronger. Because outliers can do anything to correlation. This is why we say QQ straight enough, no outliers. We do not like the outliers because they are the ones that dictate the relationship. So we would say this is true, that outliers can dramatically change a correlation. That's just facts. Riley, yeah, I'm doing chapter 6 quiz. Do you have one you're stuck on? I've already done all these questions here. I'm just rocking and rolling. Just tell me a question you're stuck on, and then I will do it. We're just doing all chapter 6 quiz right now. Or you can say, can you do this instead? And then I'll do something else instead. You're here. You get to pick the office hours. What is correlation? Correlation measures strength direction of linear relationships. It also is impacted by outliers. So what is correlation? It measures the strength and direction of linear relationships. And this goes back to the notes right here that we went over. That when we're doing correlation, it's meant to analyze strength, direction, form, unusual features. World Happiness Report, you got it. Here we go. We got that one done. Let's do the World Happiness Report, which I think is towards the end right here. Oh my gosh, it's like I've done this. Riley, thank you for being here. 1,000 points for being here. Just hop into office hours, get some points. And that question took 1 minute. This question won't, though. This question will take a little bit more than 1 minute. World Happiness Report. And then keep dropping some more questions in the chat, because we'll just do them. Okay, so let's take a look at the graphic right here from 153 countries. And this is a correlation matrix. This is the end of the notes with a correlation matrix. So when you look at a correlation matrix, the test questions, very important. Teaching to the test moments. We oftentimes ask you for the strongest correlation in a matrix. Now, we don't care about the correlation of 1 because that's kind of the variable with itself. Give me the numeric value of the strongest correlation in this matrix. Give me the numeric value of the strongest correlation with this matrix. What is the numeric strongest correlation? And not 1. We'll ignore the 1s. What is the strongest correlation? You are right, Riley. That is the strongest. But let's say it was negative 0.85. What's the strongest now? If that had said negative 0.85, what's the strongest now? What's the strongest now? Don't worry if you get it wrong. We're going to throw you another 1,000 points. It was negative, and that's why I did this, Riley. So here's a great thing. Just because, and Keely right there, great answer, and we're going to throw even more points because you might not have been here for the last 1,000 points. Keely is correct because the direction is not part of the strength. And that's some things to know for the test. So we're always trying to teach the test here. So it would still be this is the strongest correlation, even if it was negative. It would just be a different direction of correlation. Strength is determined by absolute value, and the strongest correlations have values closest to what or what. And then we're going to answer the question. The strongest correlations have values of correlation closer to what or what. Pretty much the strongest correlations have values of correlation closer to what or what. The strongest correlations have values of correlation closer to 1 or -1. The weakest correlations have correlations closer to 0. True or false? And then we're going to answer the question. A correlation of 0 means no association. True or false? A correlation of 0 means no association. Don't worry if you get it wrong. Points either way. Correlation of 0. Keely, it is false. And good answer, 1,000 points. Don't worry. It is false. A correlation of 0 means there is no what association? A correlation of 0 means no what association? Here's a hint. A correlation of 0 means no what association? Linear, you got it. So remember that for the test, because there's a lot of questions that kind of make sure you know correlation only measures linear strength. So something can have a correlation of 0, hints for Canvas content, and still have an association. Something can have a correlation of 0 and still have an association. It would just be non-linear. Okay, so this question asks, is log GDP more strongly associated with happiness or life expectancy? So we go here to log GDP, and we look at its values with the other ones. Log GDP is right here. And the answer is it's going to be more associated with the log GDP is more associated with, how am I missing it? Log GDP, there's the other one, there, yeah. It's more associated with health expectancy, healthy life expectancy. Because of this value right here. So healthy life expectancy, more associated with. And so they do make a point right here because we don't know if it's linearly. And it's going to be health life expectancy. So healthy life expectancy, but we don't know if there's a non-linear thing. It doesn't say which has the stronger linear association. It says association in general. So that's the way they say without the scatter plots, we would need to look at that to see what's going on. Does the report give evidence that improved health would result in greater happiness? Now, do we see any bad words in here? Oof. I think Mebot will get mad at this. What are bad words in our class? Now, don't say real bad words. Actually, I know a few other ones. Does anyone know any other for 1,000 points? Be careful. We're talking the bad stat words. Mebot should get mad at that. I'm going to make Mebot get mad at that as you tell me other bad stat words. He needs to learn that that's a bad word. Any other bad words in stats? Any others? Bueller? Now Mebot should get mad. So cause, and we don't like to say things like cause, except. We don't say things like cause or except. We don't say like because correlation is not causation. We don't prove things here. We just show evidence of things. We have reasons to believe things. So Mebot doesn't like words like prove. You see, he's getting really mad in the chat. He doesn't like prove. He doesn't like cause. He doesn't like accept because those are like words of certainty. We only show evidence of things. So we need to look for something that, what do you think, A, B, C, or D? Which of those talks about like an evidence of something? Like which of these sounds in line with like, well, this would be evidence of a relationship or evidence of these two things are related. And we'll do another question. Which of these sounds in line with, well, there's evidence that they're related. They don't cause each other, but they are in some way associated to which we can say that they're related. Which of those sounds like a good answer? Which of those sounds like a good answer? Don't worry, just take a guess. You're going to see the right answers here in a second anyways. B, let's see. Oh, we don't want the prove, though. Don't worry, 1,000 points. The prove is like, uh-oh. We never say prove in this class. Nope, 1,000 points. We don't say prove. We can never, and then the causation. Oh, look right here. Causation. Oh, it says because the correlation is not high, but you can't get a high enough correlation to prove it. No, because correlation never proves causation. We never prove causation. Those are all bad words. Does that make sense? Oops, don't want to submit the quiz. We never prove causation. Never, ever prove causation. We don't do that in stats. It's a bad word. So cause is a bad word, and this highlights that fact. Does that make sense, Riley? Like, let's look at the example we did right here. The correlation between height and weight is 0.60. So does gaining weight cause people to get taller? Does gaining weight, yes or no? Don't worry. Does gaining weight cause people to get taller? Just think about it like you want to get taller. You're like, man, I wish I was 7 feet tall. Exactly, Keith, right there. Gaining weight doesn't cause you to get taller, but it is associated with being taller. People, exactly. Like, which you could be like puberty. And I'm like, well, okay, yeah, there's times in our lives when we do get taller, we gain weight, but it's not the really gaining of weight that causes you to get taller. It's kind of weird. And that's the weirdest thing. It's like, I can't imagine like waking up and being like 5 feet tall, and then like a year or two later, I'm like 6'3", and that's kind of what happened. Like over like 2 or 3 years, you go from like 5 feet tall to 6'3", and you're just like, I have one memory of being on the playground, and I must have been like 4 or 5 years old, and then I remember the ground being so close to me, and I fell, and it was just like right there, and now the ground is so far away. So they are correlated, but they do not cause each other. Exactly. Height and weight are correlated, but they're not causing each other. If you gain more weight, it won't cause you to get taller, but it is true that your height is correlated with your weight, that if you said, hey, someone here is 7 feet tall, you'd expect them to weigh more. It doesn't mean they must, but there is a relationship we expect to see between people's height and weight. I'm not saying they have to follow it, because there are outliers. Does that make sense, Keely? What we mean by correlated, it's like typically people who weigh more typically are taller. Doesn't mean must or will, or prove or cause, or no. It means in general we see, because there are definitely outliers. Yeah. So that's how we like to talk in stats, is we're not saying you will get taller if you gain weight. We're saying typically we see people who weigh more are typically taller. And by typical, we mean trend in data. So good stuff right there. Okay, let's do a few more. Should we do some of the hard ones? Drop some more hard questions in the chat right here. And thank you everyone for being here. Which ones do you have? I can go back to doing these right here, but just drop one in the chat. Suppose you were to collect data. Of course. Just you can drop them while we're doing it, because then I'll just hop to the next one. Yep, that's I want you to drop as many as you can. We're gonna do as many questions as we can with the remaining time. And you can just literally drop your questions from your assignment. You can jump in here. You can be like, I'm working on this question right here. I am stuck. That's kind of the point of office hours. That's a pretty decent one. Easier than you think. Is it? Tell me if you see the number. Was it the one right before it? Did you see the roller coaster one? Okay, roller coasters. Give me the first 3 words of it, and that's usually where I find it. Most roller coasters. Here it is. Most roller coasters. I think this one is a. Not that I ever get this one wrong. We'll find out. There we go. This one, awesome. Thank you so much. Let's do it. I'll do this one a little bit quicker. Thank you for everyone. I try to throw little mini lectures in to quiz you, so I'm not just usually giving away answers, but we'll do this one a little quicker, and then we'll do another one. Okay, most roller coasters have a drop and then the length of ride or the speed they reach. And just think about it visually. You know, you go those little roller coasters that I can't even handle, I'm not joking, is which roller coaster A or B would reach a higher speed? Which roller coaster A or B would reach a higher speed? Which roller coaster A or B would reach a higher speed? Definitely B, right? So the bigger the drop, the higher the speed. That's what they're getting at. So we would see a positive relationship right here, that roller coasters that have a bigger drop in feet would reach higher speeds. Does the scatter plot indicate that it is appropriate to calculate correlation? Well, to calculate correlation, we need a somewhat linear relationship, and that's all that really matters. And yeah, it pretty much shows we can do it because it shows a linear relationship without any extreme outliers. Now, I know these are a little bit away, but whenever we do outliers in 201, we're really going to focus on giving you an outlier that is down here. So please think of the outliers as things that really go against the trend. This would be an outlier in the worst pen ever. And we don't really have anything. These are just light outliers, nothing too extreme, nothing too far away. So I would not call those outliers. I'd say they are a little bit away. No extreme outliers. Will there be free response open-ended? Nope. Multiple choice, true, false, just like Canvas content. Good question right there, Keely. We'll throw you some points. Good question. In fact, the correlation is 0.9. That is a very strong positive correlation. So it is strong positive, and we can see the first few words right there. We got it. I said be a little quicker. Drop another question in the chat. Thank you for being here. So we just did this one a little quickly because it's definitely a strong positive. Strength of the correlation is measured between -1 to 1, where -1 is also as strong as 1. It just has a different direction. Then we have things that have a correlation of 0 that are still associated but not linearly correlated. So this is associated because it has a pattern. Patterns are associations. Suppose you were to collect data for each pairs of variables. You got it. Just rocking and rolling. I already did that one. I didn't even work out last night. I'm tired. Tell me if you see the number too. I'm not seeing it. Do you see the number, Riley? The number like 23 or so. Like, is that the first few words of it? Suppose you collect data for each pairs of the variables. Did I do that one earlier? I did that one earlier, so it's none of the ones I've done. Oh, unless it's this. Oh, it's this one. It's this one. Thank you, Riley. Okay, it's 4 parts. Yeah, Riley, 1,000 points. Is this one. This is also in the homework. We'll do it here, though. It's kind of a neat one. This one will take 5 minutes to do. Not that long. It's a pretty decent one. A little bit longer, but we got it. Good thing to put in the video because this one gets people stuck. So what this question does, it was literally the one question I wasn't clicking. What this question does is it gives you, no, you're fine, Riley, 1,000 points. Hang out, we're gonna do it. Don't worry, a lot of people get stuck on this one. I've had people be like, this makes no sense. So we're gonna do it. And with this one right here, you're talking about an X and a Y variable and what variable should be the X and what variable should be the Y. The one you want to research will be the which variable, the X or the Y. The one you want to research will be the X or the Y. The variable you want to research will be the X or the Y. The variable you want to research will be the X or the Y. It'll actually be the Y. Good answers, Riley. Don't worry. It'll be the Y variable of interest. So we call it the Y variable of interest because it's the one we want to understand. So the Y is the thing we want to predict or understand. It's the one we're interested in, the one of all of our research we'll be going to. Today in class, we talked about why do you get a salary from your parents, or also known as an allowance? Well, your chores might explain it. So the X variable, known as the explanatory, will be called the X variables, the explanatories. The response is what you talk about. So think about if you're talking about something, you'll get responses about it, and you're also interested in it. So the Y variable is called the response. The X is called the explanatory. Let's do this question. So we're obviously talking about weight of an apple. And when it comes down to whether we do grams or ounces or whatever, it doesn't matter. It's tomato. So what would we see in this scatter plot? Well, weights in ounces, does it perfectly explain weight in grams? Like if you know something's weights in ounces, would it perfectly explain its weights in grams? Could you just mathematically calculate that? The weight in ounces, would it, you would see? Would it perfectly do that? You would see, yeah, it would literally just be this. It would be a perfect linear positive relationship because it's a mathematical calculation. So it'd be perfect linear positive, so positive linear with perfect correlation. Now, the next one, it depends also. These are not my favorite, the way they ask these. The next one after this I do like. But if you say, which do I care about here? It matters if I'm selling ice cream or I'm selling air conditioners. So whichever would be my X and which would be my Y depends on, am I selling ice cream or am I selling air conditioners? Now, what do you think, though? This is a good question. Do you think when there's more air conditioner sales, there's more ice cream sales, positive relationship? Or when there's more air conditioner sales, there's less ice cream sales? Or air conditioner sales are not related to ice cream sales? What do you think? What would you say? Don't worry about the curved relationships. That's not the answer. What would you say? When there's more air conditioner sales, there's probably more what ice cream sales? What would you say? Just think logically, like, when there's more air conditioners being sold, what do you think about ice cream? More or less? Actually, more. And you might be thinking, well, if people are cooling off already, they're not going to buy some ice cream. But usually, you got right there. I like the recovery on that, more points. Because in the summertime, people are buying air conditioning. And in the summertime, people are eating ice cream. So in the winter, they're like, I don't need that air conditioning. I don't need that ice cream. Still, ice cream's good in the winter, too. Fun fact. So we would see a positive, straight, linear, moderate correlation. It might not be as strongly correlated. And there's ways to outthink the question. Next one right here, I do like what they ask. Now think of you in school, and you're a freshman apparently, and you're here at UT, and you're wondering, I wonder what people's shoe sizes are. You're wondering, I wonder what people's GPA is. Which of those sounds like a more thing to worry about in academia that might be the Y variable of interest, the one we care about, the one we want to talk about, have responses about, the Y variable. Which of those seems like a more, the GPA. That makes GPA the variable of interest and shoe size the explanatory variable. Shoe size would be the explanatory, GPA would be the Y, and here's the issue. The relationship between someone's shoe size and their GPA is probably pretty, I'm looking for a 6-letter word, starts with an R. Pretty what? Pretty what? The relationship would probably be pretty what? Random. So it would probably just be a non-existent random relationship. Exactly. So it's probably just going to be weak, no direction, nothing going on. Mubot loves some randomness in the chat. And lastly, the best question they could probably ask is, you're driving in your car. Let's get in the car here. Oh, that's the wrong scene. Wrong. Wait. Oh, there's the right button. Okay, you're in your car. And with you in your car right here, you're driving along. And are you wondering, how much gas do I have or how far have I driven? What do you often wonder? How far have I driven or how much gas do I have in my tank? What do you wonder about? What's in your mind right now? How much gas do I have or how far have I driven? I mean, I know you could be thinking about both, but which of those sounds like a more logical thing? How much gas do I have, right? You might think distance, but a lot of times we're looking at that gas tank. We're like, how much gas is in my tank? You might look at the odometer too. Oh, no worries. Keely right there. We're throwing 1,000 points. You know I love all the answers here. So that would make how much gas you have in your tank the what variable. Because you're wondering about it. You're interested, how much gas do I have? That would make your gas what? The amount of gas you have left, the Y variable of interest, and how far you've driven would explain how much gas you have. Does that make sense to say? Like, how far you've driven explains why you have so much gas. Try phrasing it that way. The amount you've driven explains why you have so much gas. So number of miles would be the explanatory, gas remaining would be the variable of interest. And the more you drive, the what your gas. The more you drive, the what your gas. This will indicate the positive, negative, or no relationship. Like, I don't know, you just drive and your gas just randomly goes around. No, that's not the way it goes. The more you drive, less your gas. So negative relationship goes down. Now, it could be non-linearly if you go to places like you drive on highways versus other things. Think to the link for the Excel that we need for data analytics. Yeah. That would be Office 365 UTK. So this should be it right here. Yep. Jordan, here you go. Make sure to download it from OIT. It is free with your student access. So there it is right there. You'll log in to, go to make sure to download it though. Make sure to download it. As we said in class, you need to download it. And then also use the data analytics playlist. If you're stuck on it, please let me know. You're just making one pivot chart, make it really pretty right there. Should we do a few more? What do we got? We got in-person office hours coming up here too. Which of the following is true about the correlation coefficient? Oh my gosh. What answer is wrong on this screen? Let's do it next. What answer is just, you look at this and you're like, no. Which answer is just like, yeah, no. One of these you should just be like, there's two that are no, but we'll do this. Here are several scatter plots. B, we don't prove things. We should always calculate correlation between two variables. No, it has to be quantitative. So between two quantitative variables, if straight enough, has no outliers. Q straight enough, no outliers, plot doesn't thicken. That's chapter 7. Okay. Here are several scatter plots. I do like these questions a lot. We'll do both versions of them. Thank you, Keely, Riley, Jordan. Good to see you here. And let's go grab this. I hope people are enjoying stats. It is something I really like. The reason I like stats is because the world is data. Like, we're constantly taking in data, and then it allows you to better analyze that data and understand and make decisions based on data. So I think statistics is one of the most important things to know because it's just the analysis of data, and who doesn't use data? We got several scatter plots here. What we're going to do is we're going to first draw a line through them because correlation only measures what strength? Tell me that word as I draw some lines. Correlation only measures what strength? Correlation only measures what strength? Hence why I'm drawing a line. Key thing to know is correlation only measures what strength? Linear, you got it, Riley, right there. It only measures linear strength. Is this type Y or N, is this strong, yes or no? Is this relationship here strong, yes or no? Don't worry if you get it wrong. Is that relationship there strong? The answer is yes. Don't worry, 1,000 points. It's strong, but it's not linearly strong. Does that make sense? It's strong because the points follow a pretty nice parabola. Yeah, you got it right there. You got it because they're tight together. Exactly. That's the strength, Merritt. Yeah, it's from lecture. Perfect. Strength is how tight it is around the form. You'll need to update your Mac. Go to the Apple button. It'll be up in the top corner, and it'll be like about this Mac update. Swing by OIT if you have some issues with that. But update your Mac right there to the latest OS, and you should be able to download Microsoft Excel. And it's good for your computer too. It helps with security reasons too. Like they do updates to make sure things are secure. I should update my Mac. So that is a strong relationship, but it's non-linear. So since it has no linear relationship, R is going to be close to what? Since it has no linear relationship, R is going to be close to what? Since it has no linear relationship, which correlation only measures linear strength. Since it has no linear relationship, R is going to be close to what? It has no linear relationship. It has a relationship, it's not linear though. R is going to be close to what? I'll do the next three. Kind of, right? Yeah, you're on the right track. This slide right here can give away the answer. The answer is on this slide. It's on the bottom row. Great job, Bella. Bella coming in with 1,000 points right there. It is 0, Bella, because it is a flat relationship. These all down here would have a flat line going through them. It does not have linear strength. They can be related, but not have linear strength, so that's 0. This is like R equal to negative 0.9. It's a very strong negative. This is R equal to like negative 0.6. It's negative, but weaker. And this is R equal to like 7 or something, because this is strong positive. Does that make sense how I'm figuring out these values for these? Like this is a very strong negative, so you can find out the one that is strongest negative right here, and that is going to be answer D. D has to be the strongest negative because it goes down. This is the non-existent one. The non-existence one is closest to 0. Then this is negative, but not as strong. And then this is positive and moderately strong, or pretty darn strong. Closer to 1 is stronger, and that's got it. And I think there's another version right here. Here are several scatter plots. So the first scatter plot A should have a correlation close to what? Don't look at their answers. Just see if you can get it first. The correlation A should have a correlation close to what? Just guesstimate. A should have a correlation close to what? Because you fit the linear model through it. And it should have a correlation close to 0, 0, because it's flat. It doesn't have if you draw the density ellipse around it, it makes a 0. The tighter it is, the closer it is to 1. So which of these is stronger, A or B? Which is stronger, or B or C? B or C? Which is stronger, B or C? Great job, Keely, right there, too. Which is stronger, B or C? C is stronger. So I would say C is going to be like 0.8, and This is going to be 0.6. We're just taking guesses. And then right here, and it's stronger rally because this is tighter on C than this one. It's tighter. That's how the strength is measured. And then what do you notice about D? D is not going to be like 0.7. It has to be what 0.7? Very important right here. What do you notice about D? It has to be what? Negative, exactly. And we're just guessing. We didn't look at the answers. We're just making our own. And Bella and everyone, good practice. So we're going to see the answers. This one has to be the one close to 0. Then we have a positive, but not the strongest. So that's the positive. This one is the strongest positive, though, because it's tighter. The points are tighter. And then this one is the negative right here. So you could compare our guesses and see how we did. I mean, we did all right. It was like more like 0.9, but we did figure out the right logical ordering to them, the negative slope exactly. And we could do the other scatterplot ones because I think they're kind of fun. This one gets people. Let's do these. Is there a practice exam we can study? Yes. How do you get to the practice material? 1,000 points for anyone who drops the link. Or make Mubot drop the link. Don't write the link out yourself. Where is the practice material? Have Mubot drop that link in the chat. Yes, 1,000 points right there. There you go. Practice exam posted to it. All my things have stat to a 1. Chapter 6. Mubot has dropped the link. Check out the practice exam and write down your plan. A researcher studies high schools. We're going to do that one next here, Bella. You know what? You asked it. You're here. We're going to do that one instead of this one. Please tell me the number. Oh, wait. There it is. Thank you, Bella. You are here, and that means we do your questions. If you want those other questions done, come here and hang out. We'll do the questions. Okay. 52, 4 to 3, stat to a 1. Do we have time to do the following as property of the... Yeah, we should have to. Put the start of the question in there. Give me the start of the question. I think you have it there, but just give me the start, and then I'll find it quicker. A researcher studies. Okay. A researcher studies high schools and finds a strong positive linear association between funding and graduation rates. Does this mean that wealthier high schools generally have higher percent of graduations? So I would say yes. Because okay, A, B, C, or D. Which one of these jumps out to me? Sign 5 and S for Residual Pod. Scatterplot, Ashley, 1,000 points. Scatterplot, Ashley. Scatterplot of the residuals. Yep. Scatterplot. Good question, Ashley. I can show that here at the end. I'll put that on the list. I'll show you how to make a scatterplot of it. Which of these looks to be wrong? A is horrible. No, funding doesn't cause higher graduation rates. We can't say causation. I would say they are associated because we see that. This doesn't mean they cause, though. Better funded schools typically, generally, have higher graduation rates, but this does not imply causation. Just like people who weigh more are generally taller, there's a very strong correlation right here. But if you weigh more, it doesn't mean you are taller. We typically see people who weigh more are typically taller. What is the most likely explanation for the strong correlation? This is such a tough question. Probably not a causal relationship. It's probably lurking variable. It's probably like, talk socioeconomic stuff. A lot of times, usually access to wealth and stuff usually leads to more, it's just tough. There's a lot of things that come into play. Like you might have other things that lead to your success. And those other things that lead to your success would be lurking variables. We talked about this today in class where we talked about an example. What is the lurking variable for shark attacks and ice cream sales? I thought I put it in the notes here. What is the lurking variables for shark attacks and ice cream sales? Oh, I put it on a Word document in class. What is the lurking variable for shark attacks and ice cream sales? Which is a variable outside the shark attacks and ice cream sales. You can see it down there. What is the lurking variable for shark attacks and ice cream sales? What is it? It's down there. Do you think shark attacks cause ice cream sales to go up or ice cream sales cause shark attacks to go up? You get attacked by a shark because you smear ice. Don't do that. Month of the year, what time of year it is the variable. And so a lurking variable is a variable outside the XY relationship. It's like a Z variable. So it's probably some other variable that's not that. It's like saying, well, there's something else. It's like, do you think, because it's probably not just like, you can't just like take a school that's not doing well and be like, here's $1 million, now do well. And that's what causation would imply. It doesn't work that way.
It doesn't matter.
It'd be nice to get $1 million, but if I had $1 million, it's an old song now. Okay, dokie. Here we go. Which of the following is a property? And let's put the right timestamp. You make a good dinner tonight. I could do that. Make dinner for my wife. She'd be very happy. Which of following? Now I got to figure out what to make. I was going to make dinner on Valentine's Day, and she had already planned out dinner. That was so nice. I was like, I bought a bunch of stuff to make dinner, and she was like, oh, I was going to make tacos. And I was like, oh, I love tacos. And she said, well, you can help me make them. And I said, cool. I said, I'll help out. This is how we talk to each other. Which of the following is a property of the correlation coefficient? Is correlation always between -1 and 1? Is correlation always between -1 and 1? Yes or no? Is correlation between -1 and 1? Oh, yeah. Negative. They're the same strength, too. The correlation between X and Y is the correlation between Y and X. Rock knows.
It doesn't matter.
It doesn't matter if you switch them up. Mathematically, if you look at the equation, all the math is going to math the same way, no matter how you do it. The equation is not going to turn out mathematically different if you just switch the way you multiply, because multiplication, if you know the rule of multiplication, that doesn't matter, like 2 times 4 and 4 times 2 are both 8. So you could find all the z-scores, sum up the z-scores, and multiply the z-scores together is what you're doing. Doesn't matter if you flip the x and the y. The correlation between x and y is the correlation between y and x. You'd just be flipping the multiplication, so it doesn't matter. Correlation is not affected by units or scale. This is a fact, too. There's questions on here that say things like if you multiply every value by 2, you'll double the correlation. That's not a fact. Your correlation is actually being turned into z-scores, which can be seen here, or the x's and y's are being turned into z-scores, and z-scores are unitless, so correlation will not be impacted by changes of units or scale. As in, if you measure someone in inches or miles, which, why would you do that? I don't know. Don't do that. Then that would not change the correlation to their weight. You would still have the same correlation between height in miles and weight in pounds or stones or whatever. It doesn't matter.
It doesn't matter.
So that's true. It's not affected by those. The sign of the correlation tells us the direction, true or false. The sign of the correlation tells us the direction. The sign of the correlation, as you can see here, +1 versus -1, does that indicate the direction of the correlation? Very, very true. These are all true facts about correlation that we should know. You got it. Yeah, we've done a lot of this quiz right here. We've done almost half of it because we did everything up to question 10. Is there more like quick multiple choice ones? Oh, that is question 10. This one? The errors in the... Yeah, we might end with that one, Bella. We're doing time good. It seems tricky, but it actually relates to the question we just did. So thank you, Bella. That one is very related. And thank you, everyone. Thank you for being here. I appreciate it because it gives me the energy. If I'm just talking to myself, sometimes I get tired. It's boring to talk to yourself. We do it, but it's okay. And Hurricane Katrina, forever ago. It's like some people weren't even born during Hurricane Katrina. Because, yeah, I guess freshman. Was it 04, was it? I think it was 04. Okay, they've got Hurricane Katrina information right here. Suppose we add 120. Now, that's a shifting to the data. So remember the one we just did about shifting and scaling? What happens when you shift and scale your data? The correlations, would they change? If you shift and scale your data, would correlation change? If you shift and scale your data by adding like 120 to the values, would correlation change? Yes or no? If you shift and scale your data, would correlation change? Yes or no? Don't worry about being wrong. The answer is no. Don't worry. Some points in the chat. The answer is no. Because it would not change the whats. It would not change the whats. It's kind of like if the average test score is an 80 and you make an 80 and then give everyone a curve, you would still be at the mean. So shifting the data does not change the what. Shifting and scaling do not change the whats. which correlation is based on? The z-score. So because you're just adding, you're just moving the distribution, but you're not changing the z-scores of the underlying distribution of the data. And so the sign of the correlation would not change. And the magnitude of the correlation would not change because the z-scores would not change. It's a lot of things to click through, but it really just goes to that equation I was showing a second ago, that correlations based on z-scores. So it's would not change because the z-scores would not change. So it's saying the correlation wouldn't change from positive to negative, and the magnitude is the strength. They should have said strength. That would have been nicer for them to use the strength word. But they're just telling you that sometimes people call it the magnitude, like closer to +1 or -1. So it's not going to change in sign, which is direction, and it's not going to change in magnitude, which is strength of how tight it is, because the z-scores by which we find correlation would also not change. Does that make sense right there, Bella? So you can't just be like, we're going to add 12 to the data and make a correlation. Well, if you add it to like a data point, you would, but all the data points. So if you add it to all the data points, you would not change the correlation because the z-scores would not change. Good stuff. Any last ones? I guess I could show. Let me show here BAS 320 making a residual plot. 102 James. So tired. Z-value. BAS 320. And making a residual plot. So to make a residual plot, we're going to make a really nice residual plot. Can't even speak. And to make a residual plot, we need to make a regression. So to make a regression, we need to load up survey 10 like we just did. And we make a linear model here. Linear model of height tilde weight. Data equals survey 10. And there's the linear model. We can visualize the model, but that is a meh visualization. So what I would do is I would drop this into ChatGPT. And I would say to it, let me see here, I have a model that I want to be beautiful using ggplot2, and I also want a residual plot. Do this using ggArrange. Okay, here we go. Let's grab it. And hopefully ChatGPT is not down. Too many concurrent requests generate. Oh, here we go. That was interesting. Yeah, it's gonna be. Who knows? Maybe we'll have to like go online for ChatGPT. They're gonna get us addicted to it, and then we'll launch all the ChatGPT. So there is the two plots, and we're gonna grab it. This is the beauty. If you've never coded before, coding has become a lot easier, especially with the advent of ChatGPT. And now we've got our model. It knows the data frame and the X and the Y. We'll go here. This is the first plot being created. We did not load ggplot. We did not load ggpubr. Interesting. It's using, because ggArrange is a function of ggpubr. And here we go. That's got it. Don't like that it put A and B on it, labels. So it's already labeled anyway. So let's just remove these labels. There you go. There is a residual plot, and there is the data. This is actually chapter 7 for 201. We do a little hashtag FF8200, and now we remake the plot right there, and there is a UT orange, and we could go here, and it's 57. I think it's 575758 or so. It's about UT smoky gray. Sorry if it's not exactly right. Got some UT plots right here, and maybe we'll go a nice blue. Blue right there, and blue. Blue and red, we could do that. There we go. And you could rename the plots. Regression of height and weight. Residual plot of model. I mean, in that little of time, we were able to make really good plots. I could go ahead and write all this out. I know what like the geom H line does. It adds the horizontal line and the geom smooth. All these things right here. I can move it to the LOS method and get a bendy line to see if there's nonlinear relationships. So all of these things, and check this out 320, but this is what I want to point to, is if you know how to write basic code, like here's my linear model, and then you understand like ggplot is a really good package for making graphics. I even asked it to do the ggArrange of it. And better yet, I should be able to go in here, and I hope this will work, is library plotly. And now we should be able to go ggplotly. No. ggplotly of my GG range object. I do not know if this will work. P3. We're not going to overwrite our other graphics. And go to P3, and will this work? I've never tried this. It's mad. I think it's mad. Or is it working? No, it's mad. And let's put the plot 1 in here. Here's plot 1 in a GG Plotly. You're welcome. Thank you. And then we just access to the model by the fit. You can grab the residuals, going right here, storing the residuals. They're doing it as a data frame. You can go residuals of model. I didn't want that. I want the function residuals of your model. There's all the residuals. If I was doing this, I would go here and store into residuals or rest for residuals. I wouldn't make a basic plot like this, but there's a plot of the residuals, and then you could do it by the x variable. This is y comma x. No, it's x comma y. And so the x variable is survey $10 sign. Wait. And if you notice right here, this is a very meh version. So this is the not great version that you wouldn't want to present. What you want to present is this version over here. So here is the great version with a line where a zero residual is, and here is the m version. And you can literally see as I switch between them how this looks way better and has titles. And the code right here is the basic way to get it done. What you can also do is you could go col equals orange and do that. You do fill instead. Fill does not work. You could do AB line. This is the classic way to do it back in the day. Horizontal equals 0 and col equals blue. We're penning a code onto that. So if you look at this, you can do it all without ggplots and everything, but it's way nicer to get something that looks like this over here versus this. You can also do other themes, like you can go to the theme function right here, change it to something like classic 2, and here we'll print this graphic here. There's the classic version. You can just try different themes and see what you like. Theme Cleveland. And actually what we'll do is we'll append this onto it, so when we run the code, it'll actually show us the graphic. So now I just have to run one line of code like theme dark, and there's the theme dark. That does not work. But you can just try different things and see what you like. Does that make sense, Ashley? Like, making plots is all about no, too little information. It's all about what you like, what you want to see. That broke apparently and didn't run. But you can just change different things. And as you learn what works and what doesn't, I think I like theme. There's one I use quite often. Yeah. So you just try the void. Let's go to the void. No, that's not a good theme. You can do black white theme. That's good. It's actually a nice plot. That might be one of the best. Yeah. And then you get your plot sized up to the window you want it in. Usually we like these to be a little bit longer. And then you go to export image and you save the image, and that's how you do it. Yeah. So let me know if you have questions, and really good work. Thank you for asking, Ashley. This is how I'd want a plot to look, and you can see the big outliers of the relationship over here and down here. But this is it took very little time, and now we have a professional looking graphic. Always be thinking, do my graphics look professional? Would someone want to see this in a report? And that's what we're going for, is like professional looking graphics that if you add it into a report, it's going to look, well presented, versus if you go way back, the graphic you don't want to make is going to be this right here, which, it's not horrible, but overall it's like barely labeled right. And this is the world of difference. I should send this out and be like this graphic down here is just kind of sad. It's black and white. It's like, what are we using to make this graphic? So this is a sad graphic right here, and this is a very happy graphic. So that's what we want, is proper labels. If you think about this, this has chart title, proper label here, proper label here. This does have a label-ish. That should be in full right there. So all the differences. And then we have the extra additions and grid lines and all those great things. So make your graphics look nice, make them sparkle, make them awesome. With that, bye for now, everyone. Bye!